Hey there, this is Miss Eisencraft here with Unit 2, Lesson 5, Practice Problems Help. So looking at question 1, select all the points that are on the graph of the equation 4y minus 6x equals 12. What graph might you be asking? If there's no graph, let's just check algebraically. Well, if you recall, an ordered pair is really just the variables x and then y. It's easy to forget the order. So sometimes if you tend to do that, just put X and a Y. So one way to test if it's actually, if the point is on the graph, if it's a solution, it's on the graph. And if it's a solution, it will make the equation true. So this can seem like it's going to be cumbersome, but I'm going to give you some help. So at first, let's just replace the variables with the values and see if it actually equals 12. So on this first one, let's try plugging -4 in for x. That's the second variable here. And -3 in for y. See if it equals 12. -12 minus -24 makes 12. It does. That does work, so it is a solution. Well, that would be a lot of work, maybe going through and doing all of those. Maybe you could do it mentally, but I want to show you how you could utilize Desmos scientific calculator to help do it a little bit faster. So if I go just to open Desmos, this is one way to get there. I have it open. I'll show you from the beginning how to get there. Under Math Tools, grab the scientific calculator. Okay, so to do a split screen, I'm going to hit the window, then to the right, and I'm going to pull my quiz over here so I can see both at the same time. It's being a little bit finicky. Why? I don't know. Okay, so what we can do here, the nice thing about Desmos is you can see all of your work. So remember, I am going to be plugging in numbers for x and y, and this particular equation has y first and then x, and then the answer will spit out over here, and I will see if it equals 12. So the next number I want to choose, or the next pair of numbers I want to check, we already checked this one, is -1 for x, so that's this number right here, and 1.5 for y. Okay, that does, look over here, it equals 12. What? Yay! Okay, let's try the third one. Okay, sorry, I thought I made a mistake. That's why I'm pausing. Okay. 0 for x and -2 for y. So remember, our x is our second variable, so I'm going to plug 0 over here and -2 here. So really, the calculator is giving me a -8 because this is -8 minus 0. That does not work. So far, the first two work. Then let's try 0, 3. Let's keep the 0 there. Let's make this a 3. Hey, that one works. So this one's a good one. How about 3, -4? Oh no. 3, -4. 3 for x, -4 for y, -34. Not even close. Plugging these in backwards can really mess with my head because they're in the order of x, y here, but in the equation, they're in the order of y, x. So you really have to be careful not to make those mistakes. 6 for x and 4 for y, -20. So this is a nice way to sort of see which answer is correct kind of quickly. Okay, let's go back over here. And let's go to question number 2. Question number 2, thank goodness there's a graph for us. So it says select all coordinate pairs that represent a solution. So a solution means the ordered pair would fall on the line. So we could check algebraically, but it's probably just as easy to check the point. So 0, 2, 0, 2. Hey, that's on the line. That's good. 0, 6. It's really easy to get that mixed up and go over here. But remember, when you do ordered pairs, it's over, then up. So it's your X value, then your Y value. 2, 6. Nope. So far this was good. 3, 1. Boom, that's a good one. 4, 1. Nope. 6, 2. 6 over, 2 up. Nope. All right. I think we got that one right. Yep. Okay, let's keep going. Question 3. A theater is selling tickets to a play. Adult tickets cost $8 each, and children's tickets cost $5 each. They collect $275 after selling X amount of adult tickets and Y amount of children tickets. So, if you ever are asked to analyze an ordered pair, I'd always say, put the variable underneath my pen's acting up. Put the variable underneath the number. Okay, so if it says X is 30, well, what does X mean? X is the number of adult tickets. So that would mean there were 30 adult tickets. Why are you acting so funny, Mr. Computer? Hold on. Let's see what's going on. You're just being difficult. Okay, let me hit boom, go back here. Cancel. Okay. So again, we're checking X for 30 and Y for 7. So what does that mean? So that is adult tickets and Y is children's tickets. Okay. So what does it mean in the situation? All it's asking, what does it mean? Interpret it. And I believe this happened a lot in middle school. That means that 30 tickets were sold and 7 children tickets were sold. And because it's on the line, that means that combination also made exactly $275. So what does it mean? 30 adult tickets and 7 children tickets together make a total of 275 in ticket sales. And I can tell that because it's on the line. All right, let's keep going. Question 4. The table shows the amount of money A in a savings account after M months. All right, what happened to my little T chart? I didn't follow over in Canvas. Okay. Select all the equations that represent the relationship between the amount of money A and the number of months M. So they're calling this over here M and this A. We're very used to seeing X and Y. Sometimes when they change the variables on us, it gets a little freaky. So one way to see if this actually works is you can plug in the numbers and see if it actually works. You can even start with, it has to work for all pairs, right, in order for this to represent the table. Is this saying that the amount of money is 100 per month? Well, at first you might go, yes, because look, it's going up by 100. But there's more to the story. If you plug in 5 months, you have $500, and this is $1,200. So although it might be increasing by 100, this is not the correct equation. It's part of the story, okay? What about 100 times m minus 5? Well, let's plug in, let's see if that works for the first combination. Let's plug in a 5 here. If you plug in 5 minus 5 is 0. 100 times 0 is 0, and that doesn't make any sense. When we plug in 5, we're supposed to get 1,200. Okay, no. Let's try the other one. What about if you take the amount, subtract 700, that equals 100 times the month. Okay, let's try it. Do you get, if you take 1,200 minus 700, does that equal 100 times 5? 1200 minus 700, that's a 0, by the way. 1200 minus 700 is 500, and 100 times 5 is 500. We should probably check and make sure it works for some others. 1300 minus 700 is 600. 100 times 6 is 600. So I'm plugging in these pairs of numbers. I like to do this to remind me that they're just like ordered pairs. Okay, so this one looks good. Can you subtract 1200? And will that be equal to 100m? Well, logic would tell me I subtracted 700 and it equaled 100m, so this is not going to work. Okay, what if, can you get the amount by taking 700 plus 100m? That is probably going to be a good one, because if it is increasing by 100 each month, but it didn't start at 0, which is why this one didn't work. And it looks like because this one worked, there was something to do with 700. Like this person had $700 in their account to start, and then they were adding 100 per month. So again, you could plug them in and verify. That is a good one. Next one, can you start with 1200 and then add 100 a month? Well, let's see. If you tried to do the first one on our table, 5 months, if you plug a 5 in there, our table says you should get 1200. 500 plus 1200 makes 1700. Does not work. Last one, can you take the months, plug it in there, subtract 5, multiply by 100, add 1200. What? Well, it looks like it works for the first one. Let's see. 5 minus 5 is 0. 100 times 0 is 0. 1200 plus 0 is 1200. What? It works. Let's try the 6. Why is it telling me that? Okay. I'm not trying to navigate away, Mr. Computer. 6 minus 5 is 1. 100 times 1 is 100. 1200 plus 100. Yes, that does work as well. The crazy one. Months minus 5 times 100. Plus 1200. Okay. Oops, I hate it when I do that. Okay. Oh, that's the end. Okay, hope that helped.